Hey, secondary 2. So, welcome back from spring break. We are starting our statistic unit. Yay! Some of you are not as excited as me, but I love probability. And I think you will too. I think you'll come to enjoy this. It's a very logical unit. And the way I progress it, we progress very logically. We think our ways through things. And then I show you the formulas. I use formulas very loosely because they're coming from things that make sense. So I'm trying to teach you the logic behind what these things are coming from, and then we're building off of that. All right, so we're going to start today with permutations and combinations. We're only get about halfway through. I'm just going to get through the stuff on what is called the fundamental theorem, fundamental counting theorem, something like that. It'll make sense. Okay, so I want you to consider the following problem. You can choose one bag of chips, one soda, and one main item. The following are your options. You've got Lay's, Fritos, Cheetos, and Doritos, only one flavor each. Sprite, Orange Fanta, and Mountain Dew for soda options. And then your main options are salad, chicken and potatoes, chow mein, or tomato soup and grilled cheese. Now, you have to pick one of each item. So how many different combinations are available? So I want you guys to try this on your own. Please, I beg of you, because normally in class, this is what I would make you do. Please pause the video and try this on your own. Figure out how many combinations there are and maybe even what they are. So the way I do this, and you guys are more than welcome to do this way or any other way. Pause the video if you haven't tried this on your own. Okay, thanks. All right. So I would line up all the options for the first one. So for Lay's, from Lay's, I have 3 options for sodas. I can have a Sprite. I can have an Orange Fanta. Or I can have a Mountain Dew. Now, from each soda, I have 4 options for a main. I've got a salad, I've got chicken and potatoes, I've got chow mein, and I have tomato soup and grilled cheese. And I have that from each one of these. So soup, chicken and potatoes, chow mein, tomato soup, and grilled cheese. And then I have those 4 from here as well. Do you see how this kind of gets messy really quick? But this is actually a fairly good way to figure out how many you're going to have, because at the end, you can just count up how many end ones you have, right? So that's soup, salad, chicken and potatoes, chow mein, some soup, and some tomato soup and grilled cheese. Hold up. Tomato soup, grilled cheese. So just for Lay's, there ends up being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 different, nope, 12. 12 different options for I have to check myself. 9, 10, 11, 12. 12 different options just from Lay's. Okay, so then we would have the same thing for Fritos, which if you think about this logically, you would end up with another 12 options for Fritos. And then if you did this for the last one, or no, Cheetos. Oh, there's going to be 4 of these. So Cheetos, there'd be 12 options for Cheetos. And then there will be 12 options for Doritos. So how many is that in total? Well, that's going to be 12 times 4. Huh. Well, what if there was an easier way to do this? So there are 4 options here. For every 4 options here, there are 3 options here. So I could do 4 times 3. That'll give me 12. And then if I take these last ones, then I have an extra 4 options for each of those 3 options. So I do 4 times 3 times 4. And I get 48 options. Isn't that crazy? From 4 options of chips, 3 options of soda, and 4 main options, you have 48 options for lunch. Some will taste better than others, but you have 48 options. So here's the fundamental counting principle. It says that if there is n items and m sub 1 ways to choose the first item. So like what's that saying is there are 4 items in the first, so there is the first item, and there are 4 ways to choose, so this would be 4. First set, and m sub 2 ways, so this would be like 3 for our second set. And every item after that, what you do is you take the number of options and you multiply them together. That's what that whole thing is saying. It's very, very, wordy. So you're just going to multiply the number of options. I'm going to put number of items from each group together. And you can kind of see that from here, because for every one in this first group, there's 3 to choose from. Well, there are 3 for this one. There'd be 3 for this one, and 3 for this one, and 3 for this one. Well, that's just 3 times 4. Well, that's 12. And then for every one here, there's 4 options to choose from here. And then if we do that 3 times, that's just 3 times 4. So then we do 4 times 3 times 4. Which gets us 48 options in total. All right, let's try this out. So Sean is choosing new uniforms for the basketball team. Pants come in 3 styles, shirts in 5 styles, and caps or hats in 4 styles. In how many ways can these 3-piece uniform be chosen? So we can either write it all out in that tree diagram like I was doing above, or you can just remember our fundamental counting principle, which says we take 3 times 5 times 4. Which if we do 3 times 5, that's 15. 15 times 4 is 60. So there are 60 different uniforms. Okay. So I want you guys to try the next one on your own. If you can, pause the video. You have won 6 ribbons for various cross-country tournaments. And how many different ways can you arrange the 6 ribbons? So think about this. How many ways can you arrange the first ribbon? 6 different ways. How many ways can you arrange the second ribbon? Well, 5 different ways, because you've already arranged the first. How many ways can you arrange the third item? 4, because there's only 4 ribbons left. How about the fourth item? Well, then there's 3. Fifth item, 2. Sixth item, there would only be 1 left, right? So we do 6 times 5 times 4 times 3 times 2 times 1. So I'm going to pull out my calculator because there's no way I'm doing that by hand. And I do 6 times 5 times 4 times 3 times 2. And then if you really want to, you can do the times 1. And I get 720 ways. That's insane. That's a whole lot of ways. Okay, this process right here of doing 6 times 5 times 4 times 3 times 2 times 1, this is called a factorial. So this is a factorial. It's actually 6 factorial. And that little exclamation point is the factorial symbol. A factorial is the product of the natural numbers less than or equal to the number. So n factorial would be n times n minus 1 times n minus 2 times n minus 3. In other words, 5 times 4 times 3 times 2 times 1 would be 5 factorial. In the case that we had above, we had 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. And that was ways to arrange ribbons. So I want you guys to try this one. We already have that first one. It's 720. So look at this one. So 3 factorial over 5 factorial. That means you have 3 times 2 times 1 on top, and then 5 times 4 times 3 times 2 times 1 on bottom. Well, if you look, all of those cancel out, leaving a 1 on top and leaving a 20 on the bottom. So this is just 1 over 20. If we do 18 factorial over 17 factorial, we can line it up very similarly. We have 18 times 17 times 16 and so on, all the way down to times 1. And then on the bottom, we'd have 17 times 16 times everything until you get to times 1. Look, everything cancels out except for the 18. This is actually my favorite way to make things disappear if I need to. Okay, we have 6 factorial over 6 minus 4 factorial times 4 factorial. Okay, so this would be 6 times 5 times 4 times 3 times 2 times 1 all over 6 minus 4 would be 2 factorial, which is just 2 times 1, and then 4 factorial. So 4 times 3 times 2 times 1. So these all cancel out super nice. What's 2 times 1? 2. And what's 6 times 5? 30. So we have 30 divided by 2, and you get 15. That wasn't so bad. Okay, we do 30 factorial over 27 factorial. Hopefully you've learned that you could do 30 times 29 times 28 times, then 27 factorial would be the rest of everything down to 1, right? And then we have it over 27 factorial, so those cancel out. So then we would use our calculator to do 30 times 29 times 28. And we get 24,360. Okay, if you haven't tried one on your own yet, try this last one out. You got this. If you got 90, beautiful. Okay. Do you have any questions there? All right, I'm going to move on to this next section, and then we're going to call it good for today. All right, so we're going to be talking about something called permutations, but I'm going to show you what they are before I explain what they are. There's a reason for this. Okay, how many 5-digit numbers can be formed using all the digits 0, 1, 2, 3, 4? So, without repetition. So that means that they cannot repeat. So if we use, so we're going to have a 5-digit number. So here's the first digit, second digit, third digit, fourth digit, fifth digit. How many options do we have for the first digit if we are not allowed to repeat numbers? There's 5. How about the second one if we're not allowed to repeat? 4, 3, 2, 1. Perfect. So we do 5 times 4 times 3 times 2 times 1. This is the same thing as 5 factorial, right? So if we did 5 factorial, I'm not quite ready to show you where that is in the calculator yet. We get 120. Okay, what if we are allowed to repeat them? So if we're allowed to repeat numbers, so like the first digit could be any of the 5. The second digit could also be any of the 5. The third digit could be any of the 5, because it could be 0, 0, 0, 0, 0, right? So the fourth digit could be any of the 5, and the fifth digit could be any of the 5. So you do 5 times 5 times 5 times 5 times 5. So this is really just 5 to the 5th, which is easier to plug into my calculator. So I'd pull out my handy dandy calculator and do 5 to the 5th. And I get 3,125. That's a whole lot of numbers. All right. So consider a set of 4 objects, like M-A-T-H. How many ways can these 4 letters be arranged? So, I'm assuming they mean having 4 letters. So how many ways could we arrange that first slot? We could arrange it 4 ways. How many ways could we arrange the second slot? 3, because we've already chosen one of the letters. How many ways could we arrange the third slot? 2, and then 1. So we do 4 times 3 times 2 times 1. And we would get 24. And we could list them all. We could do M-A-T-H. And we could do M-A-H-T. And then you could do M-T-A-H. So I've almost got the 4 with the, let's see. So we've got M-T-A-H. And then we've got M-T-H-A. And then we've got M-H-A-T. And then we have M-H-T-A. Just got through that first one. Okay, that's 1, 2, 3, 4, 5, 6. That's all the ways to arrange it with just M. Does that make sense? Because that would be all of these, because we only have the first letter stuck. All right, let's try this one. So we would do A-M-T-H, A-M-H-T, A-T-M-H, A T H M. And then we would have A M T H. Or no. A H M T. And then we would have A H T M. And you can obviously repeat that same process with T and H. It's the first letters, and you would get all 24 ways. I'm not going to go over all of them just because I'm ready to move on. All right, these are called permutations. It's when order matters in a list of something, as in the case of a code. So a code, order matters. A locker combination, order matters which way you put the numbers in. However, order does not matter on who's called on to go to lunch early. If you are all going to lunch early, who cares who got called first? Y'all get to go to lunch early. Or if you're called to a committee, you don't care who got called first on that committee. That committee is still going to be made up of the same people. Nothing new. All right, permutations, order matters. And it's like a presidency. Permutations goes to presidency and order matters. So suppose we're renting the paintings at an art show. You have 7 paintings to hang and 3 vacant locations that will hang one picture. How many different ways can the 3 locations be filled with the available artwork? So how many paintings can go in that first place? 7, right? So in that first vacancy, we can have 7 paintings that go there. Now we've used up one of the paintings. So how many paintings can go in the second vacant spot? 6. What about the next one? You're right. There's only 5. So we do 7 times 6 times 5. And I would plug that into a handy dandy calculator. So I do 7 times 6 times 5. And I get 210. Okay. So there are 210 different ways to organize that stuff. So we're going to find the number of permutations of the letters in the word MISSISSIPPI. Okay. So permutations. How many options do we have for the first one? So that first letter we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. That's a lot of letters. All right, so we're going to do 11 total. But we need to notice something. We need to get rid of repeats because there are a total of 4 I's. So there are 4 I's. How many S's are there? There's 1, 2, 3, 4. There are 4 S's. And there are 2 P's, right? Yes. And then there's only 1 M, so we don't have to care about that. So normally we would just have 11 times 10 times 9 times 8, right? We'd have 11 factorial. Well, because we have these repeats, we need to divide by something to get rid of those repeats. So the way we do that is we divide by 4 factorial, because there are 4 ways to repeat I's, and 4 factorial, because there are 4 ways to repeat S's, and 2 factorial, because there's 2 P's that can be like switch places and we wouldn't notice. So this is what's going to show us what happens when we have repeats. All right, so we're going to have 11 factorial, which really means, I'm going to move this whole thing. They are taking up space in places I don't want. So we have 4 I's, 4 S's, and 2 P's. Okay, that's important information. That's where we got the 4, 4, and 2. All right, so this is really just 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. And there's a reason I did 4 factorial, because we have 4 factorial right there that we can just go ahead and cancel out with that. All right, but we also still have a 4 factorial, which is just 4 times 3 times 2 times 1. So 4 times 3 times 2 times 1 times, and then we have a 2 times 1 times the 4 factorial, which canceled out. The ones don't super matter, because when you divide by 1, it keeps everything the same. So the ones, they kind of don't matter. But I can see this. This is 2. This is an even number, so I can cross off 6. This becomes a 3. This is a 2. This is an even number, so I cross off the 8 and I write it as a 4. This 3 can cancel out with that 3, right? And then this 4 can cancel out with that 4. All right, so then in my calculator, I'm going to need my calculator to not be in the way over there. Okay, now I'm going to do 11 times 10 times 9, and then we don't do the 8 because we completely canceled that one out, times 7 times 5. And I get 34,650 ways. There's 34,650 ways to write those numbers in a unique pattern that gives you a different word. That's interesting. All right. Now it's time to finally show you that formal definition of permutations. The reason I wanted to show you this first is because this right here doesn't technically fit in the idea of permutations, but we needed to get rid of those extra copies of the letters, and this is the way we did it. All right, so here's the formal definition of the actual formula of permutations. So a permutation is a selection of a group of objects which order matters, or order is important. This is something like a presidency. Okay, so the number of permutations is the number of ways to arrange all the objects. So this was like our 11 factorial. And then on the bottom is ways to arrange the items not selected, or in order to get rid of copies. Okay, so this is the actual thing. So NPR, N means the number of objects you have to choose from. R is the number of objects you chose. So like in that number painting up here, this would have been 7P3. We had 7 objects to choose from, and we only wanted 3, and order mattered. Okay, so that's why we had 7 factorial over, so this would have been 7 factorial over, and then this was 7 minus 3 factorial. The reason for this, we only wanted 3 spots. That's it. We only wanted 3 spots, so we did that. However, on this problem, we divided by this because this was getting rid of repeated letters. Okay. All right. You can go ahead and try today's learning activity. I will be getting into, these are called combinations, next time being tomorrow. And I love you guys so much.